Welcome to Mrs. De Castro's chemistry class. Today's lesson is on covalent compounds. What are covalent compounds? These are compounds formed when two or more nonmetals share electrons. And why do they share electrons? Because they need to conform to the octet rule. Class, if you remember the octet rule or the rule of 8, it states that for an atom to be stable, it should have 8 electrons in its outermost electron shell. And of course, we said that an exception to this would be the elements in period 1, which are hydrogen and helium. Okay, so where are the nonmetals in your periodic table? These are the elements above the zigzag border. So for covalent compounds, we will be focusing on the nonmetals. All right, let's take hydrogen as an example. So if you look at your periodic table, hydrogen is an H1H. So if you remember, it has an electronic configuration of 1s1, so that when we draw the hydrogen atom, we have the nucleus here with 1 proton, and around the nucleus we have this 1 electron. Now, how can hydrogen become stable? That is, how can it conform to the octet rule? It should have a completely filled first electron shell, and that means it needs 2 electrons. So what will happen is this hydrogen can combine with another hydrogen atom so that at the end both atoms will have 2 electrons in their outermost shell. So if we were to redraw these two, we would have a case of, you have your 1 hydrogen here with its nucleus and 1 proton. This is its first electron shell with the 1 electron. And then we will have this other hydrogen atom here with its 1 electron. And then we have the nucleus. We still have the nucleus with 1 proton. So notice here now, class, that these 2 hydrogen atoms are sharing 1 pair of electrons, so that at the end, both of them become stable. So what this diagram is saying is that this electron pair now belongs to this hydrogen. It also belongs to this hydrogen atom. If I were to show this to you in a model, you would have here your 1 hydrogen atom. This is another hydrogen atom. Notice that it's showing you that this end is saying that each hydrogen atom needs a 1 electron to become stable, and that can be shown by this model right here. So if we were to redraw this now, I can show this to you. Remember, we can draw this hydrogen in this way, all right? We're with the Lewis symbol, and this hydrogen can be drawn in this way, and this molecule here we can draw like this, all right, where you now have a shared pair of electrons, right? And this is what we call your covalent bond, and we can redraw this as H, single bond H. So now this is what we call your single covalent bond, right? So with the sharing of 1 pair of electrons, both hydrogen atoms become stable. Right, so moving on, let's look at another example. So this time we will look at oxygen. Now remember, when we are dealing with covalent compounds, we are saying we are looking at the nonmetals. So you have a nonmetal plus a nonmetal sharing electrons to become stable. So let's look at oxygen. We know that oxygen, okay, has 8 electrons, and its electronic configuration is 1s2, 2s2, 2p4. All right, so you right here you have your 6 valence electrons, and each oxygen needs another 2 electrons to become stable. So if I were to draw the oxygen atom here, it would have its nucleus, right, with 8 protons and 8 neutrons. How many electron shells? It would have 2, right? So the first shell would have 2 electrons, and the next shell would have 6 electrons. Now, let's say this oxygen atom combines with another oxygen atom, right here. Right? So how will these 2 oxygen atoms share their electrons so that at the end, both of them will have 8 electrons in the outermost shell? Now, remember, we can redraw this oxygen atom as O, okay, and then it has the 6 electrons here, right? Now, and we can redraw this oxygen atom also with its 6 electrons here, right? So what does the symbol of the element represent? If you remember, the symbol will represent the nucleus and the electrons in the inner electron shells. So looking at these 2 oxygen atoms, we can look at an example like this, okay, showing that this oxygen needs another 2 electrons to become stable. This oxygen atom needs another 2 electrons to become stable. And to do that, they will combine and become this. So if we were to redraw this model, it would be oxygen, right? This is your first atom with 6 electrons. You will have the other oxygen atom with 6 electrons, right? So if you look at this, what this means is this shared pair of electrons belong to this oxygen atom. Notice that it now has 8 electrons, and this also belong to this oxygen atom. So now both of them have 8 electrons. Redrawing this model, you would have O with a double bond O. Okay? So this is actually sharing, okay, 2 pairs of electrons, and we call this now your double covalent bond. Okay, you have a double covalent bond where each oxygen atom shares now 2 pairs of electrons, so that at the end, both of them become stable. Right. So let's look at another example, right?